I'll kick off. All right. Good morning, good afternoon, good evening, folks. Welcome to another Friday and another great episode of Microsoft Networking Academy. I'm Brian Woodworth. I'm also joined here by my other black belt colleagues, Jeremy Wright, Jason Committer, and Brian Ashley. We will be on the chat side to help answer questions as necessary. We are also delightfully joined today by Fan Yang, who's the Senior Product Manager at Arista, to talk about the new virtual cloud routing platform and hybrid cloud networking. So welcome, Fan. Thanks for being on the show, and please take it away.
Thanks, Brian, for the introduction, and thanks for having me here. Hi, everyone. My name is Fan Yang. I work as product manager at Arista Network, especially on the hybrid cloud networking. So today we are going to go through some of the hybrid cloud networking topics here. And if you have any questions, there will be 10 minutes Q&A at the end of the session, and hopefully I can address some of your questions today. So here's a quick agenda for today's session. So we'll talk about some of the hybrid cloud challenges, especially in the networking and also in operational space. Second, I will talk about what is our Arista solution towards hybrid cloud networking. Third one, what use case Arista cloud solution can be used, and then will be followed by a demo. So probably a lot of people are new to Arista since we are still a small size company. So I do want to bring up like what Arista does, from a whole picture perspective. So we tend to move from pings. If you're familiar with Jeffrey, which is our CEO, she had a lot of talk on move from place in network to a place in the cloud, because we believe every place you run your network will become a cloud in the future. So on the bottom side, you have your data centers, which Arista has been doing very successfully in the data center space to help most of the cloud provider to build their cloud network. Especially Microsoft is our great partner. We also announced the campus networking last year, so we can help you to build your campus network within your building. So you can use the same leaf spine architecture within your campus. And now we also have a module network we just acquired a couple months before to help you to give you the wired and wireless experience for your campus. What will be the topic today will be focus on the right side, which is public cloud. So we do have a vEOS router as one of the product which can help you to build your leaf spine architecture within the public cloud. And we will talk about more on that in the following slides. But basically, these three places, we call this the cloud. So we can help customer to build a network in these three places. And on the top, which will be managed by Arista Cloud Vision, which is the single pane of glass for wired and wireless, and also for the NFV platform that Cloud Vision can manage. We do also have APIs for partners, for customers they can use to integrate with Cloud Vision to manage their network. And I will also talk about how Cloud Vision can help you in the public cloud environment to troubleshooting some of your networking challenges. So this is just to give you an overview, like what Arista does or what platform Arista provide today. So going to the hybrid cloud challenges here, since most of you probably are, the Microsoft reseller, or even you are Microsoft Azure customer, you must know some of the customer pain point like here, which I listed. First is about integration of cloud services. If you ever run a data center on-prem, you probably are using a lot of familiar tools the network team has been used for a while. Now, if you move into Azure, and the tools might be different. So how do you integrate your current environment with a new environment like Azure, and you can expose how do you can expose the same API or managing the same network? So that's a common challenge here. Second way is about the operation models. The tool set you are using on-prem is a little bit different than in the cloud. For example, you probably will use API or use Azure GUI to create a VNet or create a couple of route tables and also create your subnet. So that's different than your on-prem. Typically, if you're a networking engineer, you are very familiar with the standard CLI model, or you are very familiar with any of the Linux automation tools. So those are a little bit different from an on-prem perspective and also the public cloud. So there's some nuance there. So we can help you to solve some of the challenges here. The third one, which I've heard a lot from at least Arista customer, is how do you gain visibility once you move your application into the cloud, and how do you secure your application in the cloud? Azure definitely give you some capability today, but I will talk about like how Arista can help you to provide some of the advanced technology there. The first one is if you ever have a multi data center, or if you have, Azure Stack, or if you have Azure public cloud or other cloud provider, that you probably understand you need to triple the first three challenges, depends on how many cloud you have, right? So you need to think about when IT migrate their application into various public cloud. So what Arista trying to offer here, or how do we envision Arista can solve the problem, is we have three pillars here, which can help solve some of your challenges, which mentioned in the previous slide. The first one is a vEOS router. So if you are familiar with Arista switches, it's very open. I would say it's a very open platform and can help you integrate most of your applications and easy management. So we took the same EOS software that's running on the switch into a x86 box and run it as a VM version. So EOS stands for the Extensive Operating System. So which means the vEOS router has the same feature as your data center switch. So even from CLI, that's the same. Even it has the same bug. So basically, you can drop your image from your switch and put it on the vEOS router, and it can just run. So it's exactly the same with the same telemetry, and I will talk about what telemetry is and how telemetry can help you to give you visibility into the public cloud. The second one is about Cloud Vision. As a managed, Cloud Vision is the single pane of glass for you to manage your on-prem network now, because you have your EOS running on a VM in the public cloud. The Cloud Vision can manage that piece as well, since that's running the same binary, the same code. So sorry, I had some problem with the Teams. Hope you guys can still see the slides.
Yep, we can still see and hear you. Yep.
Okay, great, thanks. Yeah, so having vEOS router running either in Azure Stack or in the Azure public, what you mean Azure government cloud, it gives you the capability to be managed by the Cloud Vision and seeing all the telemetry and seeing all the information from there. And you can do the same feature upgrade, you can do the same bug alert. The third one is we have a very tight cloud integration with different cloud providers, specifically on Azure. So if you ever understand, how VNet works, there's no way to run, like for example, layer 2 there. So we need to provide a cloud HA, and we'll talk about that as well. So there's a lot of work need to be done to be integrated into the public cloud provider, and that's what we do to offer as the solution here. So what is EOS? Like why? I talk about EOS a lot in the beginning, why it doesn't matter. So EOS stands for Arista Extensible Operating System. So it's one single binary image, as I mentioned, you can use on your switch, and then now you can use it on your VM version. And we also have container version, which is called CEOS. So if you are familiar with Sonic, so Sonic is one of the open source project like Microsoft is leading, and we have a place there to help you run the CUS in your white box switches. But we also have CUS that can run in a Kubernetes environment. Like we did some webinar with Tagira, basically will help you to manage your policy in a container networking. Not dragging the conversation too far, but just to let you know, you can run the EOS across anywhere, no matter what form factor you like. So the EOS has all the features listed here. Some of them might be applicable in the routing environment. Some of them might be applicable to a switch environment. I wouldn't get into the detail here, but to let you know, it's the same EOS you have been running for the switch. Now we port it to the VM version to help you to solve some of your public cloud networking challenges. So what is vEOS router? Having said it has the same EOS features, what else do we add here? So it has the standard proving routing protocols like BGP, like OSPF. It has secure tunneling, so you can do IPsec VPN, either it's IPv1 or IPv2, or if you want to do VTX tunnels to run routing protocol over the tunnel. Also, it has the high availability built-in, which I mentioned with Azure, what integration we have done, and I will talk about that later. We also have done a lot of work to improve the performance. Since it's a virtual router, there's no ASIC per se you can use in x86 server. So we have to use CPU for packet forwarding. So we have spent quite a time in the DPDK environment to improve the performance. And I have a slide later to show you what will be the performance looks like. The state telemetry, basically it will streaming back all the information that the router knows, like what is my routing table, what is my ACL counters, what is my interface counters, back to the CloudVision. And then you can even go back to a time before, and you can see, okay, what's happening in my network. So basically it gives you a mirroring of your network environment. It also has all the open APIs, like you can use Arista API to interface with vEOS router. Because it's just a software, so you can run it on-prem, either in KVM or VMware, and we do have a physical appliance for you as well if you wanted to have a physical control of the appliance without bothering with other servers team. So you can also run the vEOS router on Arista appliance there. On the public cloud side, we have Azure Stack, we have Azure and all the other cloud support. So it's a multi-cloud virtual routing instance you can use. So here's a list of all the features we support. I wouldn't go through all the list here, but just want to pick up a couple most common feature that a lot of customers use. So you can use it for WRF segmentation, QoS for shaping, for policing. And we do have layer 3 VXLAN coming in the next release as well. So you can even extend your BGP VPN domain with layer 3 VXLAN into the public cloud on this vEOS router. Security features, we have IPsec VPN, you can encrypt your traffic, we have zone segmentation. Basically, we'll give you a layer 4 stateful firewall, and you can define different applications in different zones, and they will interact with different policies. So this slide is really about the DPDK or the accelerated networking capability we have done in the past couple months, especially with Azure. So on the left side, if you see that EOS is running as a user space agent in your VM. And underneath, for EOS or for a vEOS router to get the packet, it needs to pass a lot of layers. So you have the network card, which is basically the physical NIC, and then it will pass through the virtual switch. And then it will give it to the network driver in your guest VM, which is the vEOS router. In this case, we are pretty much about 1 gig to 5 gig range, because most of the time we are limited by this virtual switch in between. So what we have done with Azure Accelerated Networking is basically we can remove the virtual switch in between, and now the network driver that sits in the vEOS router can touch the NIC directly without letting the hypervisor be part of the data plan. So we can bypass the hypervisor with Accelerated Networking, and this can improve the performance dramatically. So as you can see now, we are about 5 gig to 10 gig range with this type of model, and nothing changed within vEOS router. We're basically just leveraging the Azure Accelerated Networking. There's some work we need to then to enable the Accelerated Networking on our side. And going further, once we enable DPDK on Azure, as you can see, we can even remove the kernel bypass within vEOS router. So now the vEOS router data path moved from kernel space all the way up to the user space. That's what Intel DPDK capability gives to you. So now you can bypass the kernel, and there's no copy to kernel and a copy to user space. Now you can get the packet from the network directly without letting the kernel know. So in that model, we are targeting 10 gig plus performance with accelerated networking and DPDK enabled in the future. And networking is in progress as we are speaking now. But today, if you are using vEOS router on Azure Marketplace and with accelerated networking enabled, which is the default option there, you will get about 6 gig, as I list here, and depends on the instance type you have. So if you're running in the D4v3 with 4-way CPU, it's about 1 gig. If you use the largest instance type we support, which is D16v3 with 16 CPUs, it will be around 6 gig. So this will be a reference for you if you are using vEOS router, or if your customer is interested to use vEOS router. This will be like a sizing guide for you. So how do you find a vEOS router in marketplace? And there are multiple offerings. The first 3, as you can see, so actually all of the license model we offer today are BYOL, and we are working on to support pay-as-you-go. In a BYOL environment here, the first 3 is about you can deploy a vEOS router with a various number of NICs and number of CPUs. So this will help you to deploy like 4 NICs or 2 NICs, a vEOS router into your VNet. But this is the Azure resource template offering. So it has to be deployed in a new resource group. If you want to deploy a vEOS router in an existing resource group, for example, if you want to deploy 2 vEOS router and you want to put them in the same resource group, then you need to use the fourth SKU here, which is the standalone image, which can be deployed in the existing resource group. So I've spent some time on the what a vEOS router is and what is the performance and how do you find the listing in the marketplace. Let's talk about what problem or use case we can solve with vEOS router. So the first is about the cloud HA, right? As I mentioned, there's no way you can run layer 2 multicast or broadcast within a VNet. So most of the gateway redundancy protocol like a VRP or GRBP, they won't work in the public cloud. But you still need the HA. If one vEOS router fails, how do you redirect traffic to another one? So we have done a huge amount of work working with Azure to integrate with Azure Managed Service Identity. So it will be easier for you to configure the authentication between vEOS router and your Azure environment. Once that's being authenticated, the vEOS router will also establish a BFD session. It's like a keep alive between these two, and it will monitor the other status. If one vEOS router fails, the other one will make API change to the Azure infrastructure and change the UDR to put into the surviving vEOS router. And the reason you have a UDR there is for vEOS router to get the packet from your host or your application, you need to have a user-defined route pointing to the vEOS router. And the user-defined route could be a default route or could be a RFC 1918 or any IP space you want the traffic to be redirected to vEOS router. So once that's been set up, if one vEOS router is down and the other one will do the failover by rewriting the UDR. And I do want to bring up the failover time. Actually, most of the failover time depends on the UDR change. So it could be in the seconds or 10 seconds range. We do have a work in progress with Azure internal load balance HA port. So this will help you reduce the convergence time dramatically. So that's probably a better way to deploy HA. But if you want to use the current HA here, you can deploy this as well. So we'll also publish the ILB HA port solution later. And this is totally cloud agnostic. If you move to another, let's say, cloud provider, it's the same CLI on the vEOS router. It's the API might be different, but we'll hide those difference for you. So we'll take the abstraction. The second use case will be if you just have 2 VNets that's in different regions or even within the same region, you can build your global VPN network here. And either from a transport perspective, you can use internet or you can use express route. And you might have the data center running on-prem, or you might have multiple data centers. You can put a vEOS router there using the appliance, which I mentioned in the beginning, and you can build this whole global VPN network to enable the hybrid cloud connection. This use case probably is more applicable if you are running a large number of VNet, and we have seen a lot of customers leveraging a hub-spoke model within the public cloud. So if you're looking at the data center, which most customers are very familiar with the leaf spine architecture, where they build a huge number of servers in their data center. So from our point of view, the VNet is very like a rack, right, which you host a bunch of your applications, or which you host your where you host a bunch of your servers. So if you want to extend the same leaf-spine architecture, actually you can deploy the vEOS router in your VNet, and then you can treat that as your leaf. Now what you just need to do is create a hub VNet, or even let's call it spine VNet, and you can interconnect them together using an overlay network like IPsec VPN. And as I mentioned, we do have VXLAN coming as well. So if you really want to build a BGP VPN VXLAN overlay network, just like your data center, you can do it in the public cloud by the next release of vEOS router. So there are multiple ways, there are multiple designs to build a hub spoke model within the public cloud. One of ways you put vEOS router in your application VNet, and then you have your vEOS router in the hub VNet, and you create the VXLAN. That's the left model. On the right side, if you are concerned about the, so there's definitely a cost factor you need to take into consideration by running vEOS router, either from a license and also from a compute perspective. But it does bring benefit to have vEOS router in the edge of the network. But if you can live with that with Azure UDR, you can also do that without running vEOS router in the edge. If I have UDR there, as I mentioned, this is like extended topology from the previous slide. The UDR will either have a static route like default route or RFC 1918 pointing to the vEOS router in the hub. If one fails, the other one will feed over the UDR. So it's kind of the same model, but you just extend it to multiple VNets there. And you can use peering from a VNet peering from a transport perspective. And this can help you to scale to hundreds of VNets. And this will give you the visibility and the state telemetry, depends on where you deploy the vEOS router. The cloud vision will be the same single pane of glass for you to manage your on-prem, if you're looking at data center, which is Arista switches, and also your public cloud networking, which is a vEOS router. So the next use case is about encryption. If you want to really encrypt your express route from end to end, you can extend the previous topology back to on-prem, but using express route as your underlay network or as your transport. So now you probably have an express route gateway dropped in your hub VNet here. Once that express route gateway has been dropped in your hub VNet, your vEOS router in that hub VNet can talk to a vEOS router appliance or any Arista switches in your data center using private IP space. Once that connectivity has been built, you can create an IPsec tunnel from that vEOS router back to on-prem, and then you can encrypt the traffic over that express route. You might have a question like, if one vEOS router is only capable of 6 gig, but what if I'm running like 10 gig express route, or what if I'm running 100 express route? How do I encrypt that amount of bandwidth, right? You can horizontally scale your vEOS router in your hub VNet to multiples. And then as long as your on-prem device support ECMP, which is equal cost multipass, then it will load sharing the traffic across multiple tunnels towards the vEOS router instance in the cloud. So that will help you to enable to help you to build a highly scalable IPsec encrypted tunnel from your cloud to your on-prem environment. And you can leverage the Cloud Vision configlet to build IPsec sessions. So you don't have to really log into the vEOS router and do a bunch of CLI. You can use the Cloud Vision, which is your single pane of glass, to configure a vEOS router automatically. Excuse me. The next use case, which I talk about, is more on the security side. So if you want to segment your traffic within your public cloud, there are multiple ways to do that, and depends on how granular control you wanna have. So we introduced zone segmentation, which is like a firewall capability on the vEOS router last year. It's also a cloud agnostic features, so you can run it across anywhere as long as you have a vEOS router deployed. So basically what zone segmentation does is you can define your traffic, and you can put that traffic in different zones. So the traffic could be something that coming from a single interface, like a physical interface or tunnel interface, or you can use ACL to define a subnet of the traffic you want to put that in the zone. And by default, it's a zero trust model. So all the traffic that's within the same zone can talk to each other without any configuration. You don't have to do anything. But if you want zone talk to another zone, it's not allowed by default. You have to define a policy between two different zones so they can talk to each other. So mapping the technology back to the public cloud environment here. So if you have a vEOS router deployed in a VNet, which is close to your application, then what you can do, you can define, okay, my subnet 1, it belongs to application. My subnet 2 belongs to my test environment. My subnet 3 belongs to my production environment, right? And then you can segment the traffic. Basically, you can have vEOS router put 3 interfaces in different subnet, and then it can be segmented. If you only have vEOS router deployed at the hub side and you are using the Azure UDR model, which I talked about in the previous slide, then you can define the traffic from using the subnet model, which I mean by using the ACL to define your traffic. And you can say, okay, the traffic coming from this interface or coming from this side with a certain subnet belongs to our segmentation or belongs to a zone, and then they can talk to each other if they belong to the same zones. So it really depends on the model you deploy your solution, but it can help you to extend your segmentation from one VNet to another VNet, or even let you segment your traffic within the same VNet. So it's a stateful enforcement, as mentioned. So if the traffic is allowed on the other side, the return side will be automatically allowed. As I mentioned, everything you need to configure a vEOS router can be done through CloudVision from a central management or central provisioning perspective. And the CLI here is very familiar to the network ops if you guys are already running a data center network. The visibility and automation, which is through the CloudVision. So if you're looking at the left side here, the CloudVision can manage your physical switches, as I mentioned in the beginning, can manage your virtual router, which is in NFV environment or in the public cloud environment. It can also manage your container CEOS. So it's really a single pane of glass to do your change of control, to do your provisioning, to do the telemetry. I will talk about telemetry in the next slide, but here, let's talk about the Cloud Tracer for a moment, which is on the right side. So what Cloud Tracer does is help you to enable the hybrid cloud networking visibility. The Cloud Tracer is a feature that's running in the EOS software. So you can enable the feature in your switches. You can also enable the feature in your vEOS router. What it does is basically probing the destination. The destination could be an Arista resource or could be any resource that has a TCP port open or has the HTTP port open. So it will give you the metric about HTTP response time if it has the HTTP server set up in the destination. It will give you the jitter, latency, packet loss towards that destination. For example, in this environment, if you have your multi-region deployment in Azure, now what that's from a data center, you can configure that Cloud Tracer feature on Arista switch or on the vEOS router appliance or just on the vEOS router. It will monitor the connection into your different regions, and then it will take the information back and then streaming it back to your CloudVision controller, or not controller, management tool. And then you can visualize your latency, jitter, or packet loss from a single pane of glass. And you can also go back, like, for example, if there's a network outage in 3 a.m. in the morning and nobody's monitoring the network, but now when you wake up, you're looking at your Cloud Tracer port application in the CloudVision portal, you see there's some red signals, and it's telling you that you had some problem in the morning. So it can give you the capability to go back and figure out what's happening. That's just about from a connectivity perspective. The vEOS router is also streaming back its state. What I mean by that is it will stream back the route tables, it will streaming back its interface counters. So correlate those information with CloudTracer will give you an overview on what's happening, or what was happening at 3 a.m. in the morning. Like if there's a route loss in the vEOS router, which are causing the outage, or if there's some ACL counter that's misconfigured that's blocking the traffic. So by using all this information can help you to recover the network state which happened before, and can help you better troubleshooting your network environment. So I talk a lot about CloudVision, but here is what CloudVision can help you to manage your multi-cloud environment, including your data center, including your campus, including your public cloud like Azure. So let's talk a little bit on the CloudVision, like what we offered as one of the integration with this hybrid cloud solution Arista offers. So one of the use case or solution we offer here is now you can manage your vEOS router instance or some of your Azure networking from CloudVision. If you are a heavy Arista customer and you are very familiar with CloudVision, now what you can do is you can create a vEOS router from your CloudVision. So looking at the field here, you just need to fill out your Azure credentials. You just need to fill out your instance names, and it will automatically drop down the list. It will give you a drop down list so you can select from like which VNet you want the vEOS router to be deployed, what security group you want it to be associated, do you want to have a public IP address, and so on and so forth. So now you can just create a vEOS router from the CloudVision directly, and we do have it for other cloud support as well. So once that vEOS router is being provisioned, you can manage the vEOS just like the way you manage your physical switches. And it will also include the license installation. So you just need to import your license into the CloudVision. Once the vEOS router is created, the license will also be provisioned by the CloudVision. So now your vEOS router is up and running with the correct license. Visibility across any cloud. So this is the state streaming telemetry I talked about previously. And this is just some examples like what is included in this state streaming telemetry. So you can get your interface counters. What is my speed of specific tunnels? What is my speed of a specific interface? Is there any job on that interface? You can see the routing tables, like what is my BGP routing table look like? What does it look like 3 a.m. in the morning? What is my CPU utilization? So it gives you everything that vEOS knows about itself and also about the network. Once it stays streaming, it's real time. So once you change something there, it will reflect the change within a second. So it's not something like SMP, which probably is like 5 minutes polling interval. This gives you the real time visibility into the networking you're running in either Azure or you're running in the physical data centers. So this is one of the example which are telling you what is the value of telemetry. So on the left side, this is typical. If you're a networking engineer, you are pretty much very familiar with the CLI here. So if you want to see the interface discard, you show interface counters. And you might need to run this CLI multiple times just to catch that interface discard or just to catch that interface errors, right? But on the right side, which is more modern way or easier way to make your life easier, which is you monitor all the statics from CloudVision, which is the central single pane of glass, right? You can see the packet job when it happens, and you can go back to say, oh, what is the packet job rate? So this can help you to troubleshoot the network easier, and this can be used with vEOS router as well. So for example, you have vEOS router running in your hub VNet, and somebody's telling you, okay, I have a problem logging into my VM in a spoke VNet. And that problem probably happened like 1 hour before, and he's just telling you the problem now. You can go back and see, okay, what's happening in my network? Is there a route job, or is there ACL that's blocking the traffic, or is there interface packet job, or if there's a spike in the network? The example down below, which is giving you example on the route change. So if you're looking at the red block here, which telling you, okay, this specific route has been removed at what time, right? And this is very typical. This is a very typical use case where your device is paired with other device, and the other side might just withdraw the route for no reasons, and you want to go back and see if that's the case, and this will give you a view on that. When did the route change? Is that the route causing the problem for you, or if it's other problem? So it will give you a holistic state approach to help you to troubleshoot your network. So what's upcoming next? As I mentioned, we are also working on the DBDK support for higher performance. We support accelerated networking now, but once we can enable DBDK on that accelerated networking instance, you will see about close to 10 gig performance. Today we can do 6 gig, just from a summary perspective. We are also working on to support pay-as-you-go. So with pay-as-you-go, you don't have to contact Arista to get the license. You can just run it by hour, and then you are paid to Azure directly. So it's really a way to enable, like, to run software in a public cloud. From a feature perspective, we are working to support layer 3 VXLAN in the next coming release, which will be Q2 this year. With layer 3 VXLAN, now what you can do is you can extend your universal overlay network from your on-prem environment all the way into the public cloud. And this is a cloud agnostic transport, so you can run it in multiple public cloud. We do have path selection and path telemetry, which I didn't list here, a feature coming. So basically, it will help you to find out what is the best way to reach out to the other side. You might have multiple paths between two sites, and then it will, if you have MPIs, if you have internet, or if you have multiple internet circuit there, it will help you to discover all the possible paths between those two sites, no matter how many transport you are using. And it will also monitor the paths between these two, and then you can define your application, and you can put your application SLA into different paths. So it will help you to leverage all the bandwidth between two sites, and it will do all the path selection for you automatically. So that's also coming for the Q2 timeframe. So with that, I'm gonna head to the demo. The first demo will be use a config.lat to build IPsec tunnels. That's on the CloudVision, which will show you the central, the single pane of glass of managing your overlay network within the public cloud. Second one will be how do you troubleshoot in the hybrid cloud workload? Like if there's a problem within your hybrid cloud networking, how do you troubleshoot that from Arista perspective? So so this is a pre-recorded demo. So I will walk you through the video here, and hopefully you can see the. Okay, I think you can see the video here. Yeah. So this is, so just to give you a little bit idea what's happening here. So this is the CloudVision, which I talked about in the previous slide, where it's the single pane of glass to manage all your Arista network. Once you log in, you can see there's a vEOS router in this topology view, which is under Azure. What you can do is you can manage it and then click config.lat. It will lead you to this page. So what a config.lat does actually is a configuration template, and you can define your own configuration template based on your requirement. So what I define here is basically IPsec configuration template, and this is totally open. So I publish in Arista GitHub, and if you want to just download it, you can download it. So the config.lat will give you a couple options to get your input. So what will be the tunnel ID you use on the vEOS router if you want to build the IPsec VPN? What is the IP address of the tunnel, and what is the source of the tunnel, and what is the destination? So this is the destination, and the tunnel local ID basically is the router public IP. Since vEOS router is sitting behind the NAT in Azure environment, you need to tell what's the public IP here. So the generate, once you hit the generate button here, it will create a bunch of configurations. Once you land into the next page, what is good on the CloudVision side is it will give you a diff of the configuration of the future state and your current state. And this highlighted green are telling you, okay, these configuration are going to the router if you click save, and then there are a couple processes you need to do. But this tells you what's going into the router. And you can see this is just standard IPsec configuration. And there's the tunnel configuration here as well. Once you click save, so this is typically the way the network design team they want to do, or network operational team want to do. And we also separate the step from just configure the router and sending the configuration to the router. We'll make that separate step. So now if you go to the task here, you can see the task is pending. So if you're network administrator, you can actually, and here what I want to show is there's no tunnel configuration. Before we hit the approve button, just to you what is the original state here, just the interface IP and also the loopback IP here. There's no tunnel. As a network admin, you can just approve the configuration, and then the configuration now will be finally sent to the vEOS router. So now if you go back to the console here, if you do a show IP interface brief, you can see the tunnel configuration has been provisioned to the vEOS router. If you are running or if you are managing a large number of Arista device, this function is very helpful to you. So you can define a lot of config-let, and then you can apply the config-let to different instance, and then all the instance will be updated at the same time. For example, your AAA configuration are the same across multiple devices. So this is the first demo about the using CloudVision config-let to manage your multi-cloud IPsec VPN network. The second one I'm gonna try to share with you is how do you troubleshoot an environment in a public cloud that has some connectivity issues. So this is a shortcutted video, so it plays very fast, so I will pause in between. What I'm trying to get the problem here is I'm pinning from a data center server to a public cloud instance running in my Azure environment. And as you can see, I don't get any response. And that's a very typical use case. Developer telling me, okay, I cannot log into my VM in Azure. I need to build some application there. And once you go to your CloudVision portal, you have vEOS router enabled in Azure. And as mentioned, the Cloud Tracer, which will basically tell you, okay, how is my cloud networking looks like. So I have my vEOS router data center on the left here. The right is telling me, okay, I have a connectivity problem with Azure application VM, but my Azure vEOS router looks fine. So this means, okay, there's some problem between my Azure vEOS router and my Azure VM, right? So that's a typical use case. So now what I'm showing up here is you can actually log in to your Azure vEOS router, and you can do a TCP dump, and you can specify the source of my client, which is the application, which is the developer's VM. And the TCP dump is telling me, okay, I only have ICMP request, and there's no reply coming back. So that typically means there must be something missing on the Azure side, that the return traffic is not working. Either it could be there's a missing route, which is the case I'm going to show to you right now, or if there's some firewall which are blocking the traffic. But it's telling you, okay, the WAN circuit, which is from your data center to the vEOS router in the Azure, looks fine. And there's something happened from your vEOS router to your Azure VM. And what it does here is basically there's a missing return route in your Azure environment to pointing back to the vEOS router. Once you have that configured, now you will start to see the reply from the TCP down, and then from a connectivity perspective, it looks okay. And now if you go back to your Cloud Tracer, you can see this is really sub-second update here. Oops, sorry. This is a sub-second update, which are telling you, okay, the problem is going away. So yeah, so that was my demos for today's session. If you want to find more information, here are some links that you might be interested, which is the vEOS router datasheet and our blogs. And there are a lot of good content in Arista EOS Central, but you do need a Arista account. It's open to everybody. Once you register account, you can see a lot of blog and great articles there. Yeah, having said that, I think that's it from for my presentation today. I think we are pretty much on time, and we can address some of the questions.
Hi, Fan. Thanks for the presentation. Really enjoyed it. I was wondering, does Arista plan on leveraging or using any exclusive Azure features as part of their Azure offering? As an example, we have something in preview called Azure Virtual Network Tap, which captures packets on the fly. Again, that's just one example of an Azure exclusive feature.
Yeah, we are definitely open to look for the option. I think Azure, especially for Azure VTAP, yeah, we are actually looking at we look at that before, so we are looking to do more integration with the Azure specific features, like the ILB. I think that's more like Azure specific.
Thank you.
Any other questions? I thought there's a question on the license, right?
Yeah, there was a question about demo licensing. We were thinking, Jeremy was seeing that there was a free 60-day trial license in the marketplace. So if you want to just talk about that a little bit.
Yeah, there's a free trial license out there in the marketplace. You can just spin the vEOS router up, and then you can just use it for 60 days. But if you need a trial license, you can contact, I think I have my email pointed in the beginning of the slide here. You can contact me, and I can get you in contact with Arista salespeople, and we can get you the trial license, or I can give you the trial license as well. So my email is fanyang@arista.com.
Hey, Fan, is that the trial license available in the marketplace? The free 60-day version, is that performance capped, meaning only X amount of throughput?
No, I don't think there's a performance cap there.
Required demo key.
Yeah, but if you ever run into the performance, you can contact me. I can give you the performance license.
Okay, thank you.
All right, folks, any other questions? It's great to have Fan on the show. It's a good opportunity if you're working in any place where you yourself or your customers are have Arista as a partner. It's a good chance to ask any questions. But he covered a lot, so hopefully he answered those questions for you.
Yeah, I do see some questions there, discussion around the LB. Yeah, I think we are working on it to validate the design, which will give you the reduced convergence time. But even if you do the current HA model with our cloud HA, it's still active model. So it's primitive. If one vEOS router fail, once it comes back, there's an interval you can set, like after 30 seconds, it can make itself primary. Because sometimes you might deploy your application in different availability zone, and you always want to leverage the same vEOS router in the same availability zone as your primary. So we do have that active support today.
All right. Well, thank you, Fan. Thanks, everyone, for joining today. If I can get my act together next week, we'll talk about ExpressRoute Global Reach, but I would like to try to build a lab out for that, so that might push that date out a little bit. But stay tuned. We'll find a good topic for next week. Thanks, everyone, for joining. Thanks, Fan, for being here, and a great demo and expose on the Arista solution. Really appreciate everyone's participation as always. Again, this is posted to YouTube. I'm going to get the last several sessions posted to YouTube, hopefully early next week. And of course, we'll notify folks when that occurs. So everyone have a great Friday, a great weekend, and we'll catch you soon. Thank you.
Okay, thanks.
Thank you.